Good day, everyone, and welcome to today's physics class. In today's physics class, we are going to be discussing the basics of this topic, moment of a force. If today is your first time of coming across this my page, I want you to consider following me, hit the like button, share this post to get a greater number of students on this platform. So this particular topic is captured in our grade 11 scheme, which is SX2 here in Nigeria. So I want you to listen and watch. I will be discussing everything that you need to know about moment, as well as what discussing the conditions of equilibrium. Now let us look at moments. Let's talk about moments. Now, what is moment? Then, what is moment of a force? Remember, force is very important in the sense that what, when we are talking about motion, we must not forget force, because it is force that causes motion. Apart from the tendency of a force to accelerate the body, this same force can also cause a body to rotate or turn about a point. And that point or axis, that point is known as the pivot or fulcrum. So we call that pivot or fulcrum. Good. Now, since a force causes a body to rotate about a point or turn about that point, which is known as the fulcrum or axis. So the turning effect of this force is what we call moment. So therefore, moment is the turning effect of a force about a point. Or simply put it in a way that captures everything. Simply say moment about a point. The moment of a force about a point is the turning effect of that force about that point. That is the definition. Now let's all look at real life scenarios where we see application of moments. Let's demonstrate, for example, look at the door handle. When you want to open the door, what you do, the handle is fixed at a point, then you turn it. Then when you want to open it, you turn it clockwise. You see, turn it like this is a clockwise. Then look at the tap where you fetch your water. Then what you do, you turn it like this. Then when you want to lock it, you lock it. That point is fixed and you are turning it. So that is moment. So the turning effect of that force. So moment is applicable in real life. In our lever system, we have lever system as a simple machine. We look at the crowbar, the nut cracker. So you see that the principle of moment is applied. Like the scissors, you holding a scissors. The scissors is at a point where you want to cut it. There is a fixed point there. Even the wheelbarrow. So all these areas are where principle of moment is in action. Now, what are we trying to say about moment? This moment of a force now, to get the magnitude of this moment of a force, the magnitude is the product of the force and the perpendicular distance from the line of action of that force to that point. Look at it now. What are we trying to say? If this is a point where we want to fixed, and this is the axis. Now, this is a force. This is a force, and that could be a load, or it could be a child sitting here. What will happen when the force is placed here? What will happen? This body will be turned, or you can decide to turn it this way. Then let's say we put another force here. Okay, this is F1, this is F2, and here is the point of turning. This is called the fulcrum, or the pivot point. So this force will cause this body to either move down to this way or move to this way. If this F1 here is greater than this F2, what will happen? This body will move down to this way. It will turn and move towards this direction. But if this F1 is greater than this, if F2 here is greater than this F1, what will happen? This body will turn to this direction. So this turning effect is what we call the moment of the force. And now the magnitude of this moment we're talking about is the product of the distance, the product of this force and the distance between this perpendicular distance. Look at the distance is perpendicular. to this force. So from this line of action to what? To this point. This is the line of action. So this distance for the line of action of this force to this point. So we measure it. So our moment here is equal to what? F1 multiplying the distance, which is what? X. So the distance here is X. So moment is a vector quantity. So the SI unit of moment is Newton meter. So that is where we have Newton meter. So this is the SI unit of what? Moment. You can simply say Newton meter. So it is a vector quantity. Okay. Now, from there, we then look into the principle of moment. So there are two basic principles of moment which we normally apply in equilibrium. So moment of a force is applicable in equilibrium of a rigid body. So this one is talking about the equilibrium of what? A rigid body. So that is it. Moment is very important, and the distance which is perpendicular to the line of action of the force. So it's very, very important. So let's look at the principle of moment. And before we go to the principle of moment, there are two major types of moment. Let me illustrate it here. Let's use the diagram to illustrate the types of moment here. Now let's look at this is the point at which the body will turn. And remember, we call this what? Fulcrum. Okay. Let's assume this is force 1, F1, and this is force 2. And now, for example, there could be another force here acting upward. There could be another force here acting upward. Then what will happen? When taking moments, distance is very, very important in moments. You must be able to calculate and identify distance to which each force is what? Perpendicular. Now look at this one. For example, this is the fulcrum where we are taking moments. We are taking moment from here. The distance that will be perpendicular to this F1 is from here down to this point. We can call this one, since this one is F1, we can call this one X1. Then this one can be what? This is F3, and this is what? F4. Now look at the distance. This is the fulcrum from here. Then the distance that is perpendicular to this F3 is this one to give us what? X3. Now look at X2 from here down to this point. That is the distance when taking moment about this point. So this is your X2. Then why from here, this point here, this is the line of action of this force. So the distance will be from here to here is what? X4. Now we want to look at the types of moment we have here. There are two major types of moment. The first one is what? Clockwise moment and the anti-clockwise. In terms of sign convention, clockwise moments, clockwise short form, clockwise moment is negative, okay? It's negative in sign convention. It means we are turning the opposite way. Then why the anti-clockwise moment? This one is positive, okay? So in case you are asked in your exam condition, they ask you in terms of the turning effect of the force, which of the moment is negative in sign convention or which one is what? Positive. So you should know that what? The clockwise moment carries what? Negative what? Sign convention. And this one is positive. Now, where do we see the clockwise moment? Now, let us use this diagram to illustrate. Now, look at, you can turn like this. You are turning like this, okay? The body could also turn this way. All right. Now, from the down like this, you can go like this, okay? And you can also turn like this. Now, since we said that what? This is the turning point. And the turning effect of each of the force is the moment we are talking about. Now, according to the principle of moment, it says that what? The algebraic sum or the vector sum of the moment about this point, the vector sum of the moment about this point is what? 0. That is to say, the clockwise moment, remember, the sum of moments now should be what? Clockwise moment plus anti-clockwise moment, which is equal to 0, according to the principle of moment. So both of them add together, which means one of them should be positive and the other one should be what? Negative. So like I explained earlier, the clockwise moment carries a negative sign convention. So in that case, the sum of the clockwise moment is equal to the sum of what? The anti-clockwise moment. And remember, the force we are talking about here, which causes this body to rotate, is a vector quantity. So we can say that the vector sum of all the forces in one direction must be equal to what the sum of the forces in opposite direction. That is what the second law says. Now, the other one says that what the algebraic sum or the vector sum of all the forces now acting on this what body, for it to be in equilibrium, so it must be what 0, which means the sum of the upward forces must be equal to the sum of the downward forces. That is what the law is talking about, the principle of moment. Now let us look at the clockwise moment from here. Which one is clockwise? Look at when the moment is going like this, it's coming like this. This is called clockwise. Look at this direction. As it's coming like this, this is the clockwise. Why this one that is coming like this is what? Anti-clockwise. Now look at the force that will move clockwise and the one that will move what? Anti-clockwise. Look at the fulcrum here. This is where we are going. So it means that this F4 is coming this way. It will turn this way. That means it is coming this way. Then F3 is not coming this way, as this arrow is showing here. No, this arrow here does not affect this. This arrow here affects this what? F4. Now look at this F3. F3 is going this way. It's turning this way, which means F3 now, the moment we are going to have here should be what? Clockwise moment. Then, which other force again is having clockwise? Now look at this one, F2. F2 is coming this way. Are you seeing that now? So F2 is coming this way. This one is clockwise. So this is clockwise moment. Then this one is also what? Clockwise moment. Now, where are the anti-clockwise moments? Look at anti-clockwise. Look at this one. This one is anti-clockwise, and this one is anti-clockwise. Look at, it's coming this way now. Then F1 is going like this. That both of them are moving in the same direction. So in this analysis, you should be able to identify which of the forces, it could be several forces acting on a body. And now let us look at this body now. Look at these forces now acting on this system. These forces are what? Parallel coplanar forces. That means they are acting on the same plane. Or we'll talk about coplanar. It means, well, they are acting on the same plane. Now look at here, they are parallel. This one is parallel, going this way. Their line of action can never coincide. So which means they can never meet at all. So these are what the action of parallel forces, the condition for equilibrium under the action of parallel what? Forces. Look at it here. And remember I said that this equilibrium system is for rigid bodies. This is for rigid what? Body. Now, the upward forces, which means F1. So we have, for the first condition, we have F3 plus F4 equal to what? F1 plus what? F2. For condition of what? Equilibrium. So for equilibrium to what? Exist. So the whole of this, if there are 3 or 4 forces acting upward, so we must add them together to give us what? Equal to the sum of the downward what? Forces. Then the clockwise moment here, what is the clockwise moment? Like I said earlier, this one is going like this. F3 here is going like this, which means F3 multiplying, what is the distance? X3, then plus, which other one again is clockwise? Look at F2 coming this way. So plus F2 times X2 equal to, now anti-clockwise is F4, then F1. See that? We have F1 times X1 plus F4 times X4. So this one is what we are talking about, the principle of moment. Okay. Now, what if we have other conditions? All right. Now, let us look at this diagram on the board here. This is a system in equilibrium. And now, for us to balance this body, let's assume this is a meter rule. And this is a meter rule, okay? Now, there is a load here, 10 kilogram, or it could be 10 grams. Let's put gram here, okay? So let's call this one 10 grams. Now, what must we do to make this body be in equilibrium? Which means we require another 10 grams to be put here, okay? There has to be another 10 grams so that this system can be in equilibrium. What if in a situation where this ground is removed? What must we do to make this body to balance so that the body will not move to this way, so that it will not turn down to this way? What will happen now? It will move down to this way because we place it here, and this is at the middle of the meter rule. So this is the center of gravity of this meter rule now. Now, the only thing we must do is to keep adjusting the distance. So when we adjust these points, or adjust the meter rule, we stretch it to the other side, extend it, so that the closer the load to the fulcrum will give us the balance point. What am I trying to say? In a system of equilibrium, or in taking moment about a point, distance is very important. So distance also plays a major role in balancing the body in a system of equilibrium. So when you are taking moment, make sure you consider each distance. So every force must have a distance where the body must balance. Now, what will happen now? I will adjust this body. The only way that this body now can be in equilibrium is to adjust the meter rule. We keep on adjusting. So it could be adjusted to this point whereby the mass will be too close to the fulcrum. So from this point, the meter rule can balance. So what I'm trying to say, distance is very important. Even if you don't have to put another mass here, then you can just adjust the distance. So the closer the load to the fulcrum, so the balance point we are going to achieve. So stable equilibrium. So we have to move on to another aspect because of the length of the video. So in my next video, I will give us the conditions for equilibrium under the action of three non-parallel coplanar forces when they are acting at a point. So how do we achieve equilibrium of forces, as well as solving some other examples and doing some calculations on this topic. So I want you to like this post, share this post, and do well to subscribe to my physics and mathematics lover on YouTube. So you are going to be seeing a lot of my video lessons as you do so. God bless you.